Hello, my name is Carlos Campabadal. I'm an outreach specialist in feed manufacturing and grain storage and faculty at the International Grains Program Institute, or IGP Institute, of the Department of Grain Science and Industry of Kansas State University. These lectures are part of the Soybean Excellence Center through its feed manufacturing track on the basic level. The next presentation will be on storage and grain quality management. For this lecture, we want to learn the following objectives: understand the principles of grain and feed ingredient storage, learn about the factors that affect grain and feed ingredient storage, learn how to apply different grain storage practices to maintain quality. It is very important to have good storage practices because it will help us maintain ingredients and finished feed quality, and also it could help us reduce mold growth and the potential of mycotoxin production during storage. Keep in mind that the molds that can produce mycotoxins during storage are the Aspergillus families that can produce aflatoxin and archaetoxin. The rest of mycotoxins can be produced in the field. Also, good storage practices will help us reduce the risk of compaction of feed ingredients and feed in silos, hoppers, and flat storage. It will also help us reduce shrink losses due to insect infestation or moisture loss, and very important for food safety, good storage practice will help us avoid cross-contamination of microorganisms and pathogens that could end up in the finished feed. When you're storing feed ingredients, grain, oilseeds in tropical weather or semi-tropical weather, it is very important to understand that grains, and in particular corn from any origin, are normally very susceptible to spoilage by mold. Therefore, it is key to understand the weather conditions in your location. Tropical weather conditions are usually when the average temperature is higher than 28 degrees Celsius and the relative humidity, which is the amount of water that is in the air in vapor form, is higher than 65%. This is also the ideal conditions for mold to grow. U.S. corn has a tendency, but its quality will also depend on many other factors like agronomic, handling, and storage conditions. When we think about the typical diagram for animal feed manufacturing, the storage portion usually goes after receiving. You receive the ingredients, you measure its quality, and then you put in storage that could be on a metal silo, concrete silo, warehouses, even in bulk, and also in bags in the same warehouse or other locations. When we're talking about storage, there are several concepts that we need to always have clear in our mind. First of all, feed mills usually have limited storage capacity that in some cases it could cause problems, especially when trying to buy feed ingredients at a better price and need to buy more of it. There is a loss of inventory called shrinkage that is generally usually not well quantified. The storage of grains and feed ingredients is based on the variables of temperature, relative humidity, and its own moisture content, that is the whole internal amount of water. Good quality of feed ingredients and storage practices will result in good quality finished feed. This diagram represents all the factors that affect grain during storage. The representation that I use for teaching purposes is based on storing corn, since it's a little bit more susceptible than other grains and oilseeds, that you can see it there by the yellow color in the grain mass, and also metal silage, which is one of the most common storage structures that are used worldwide. To start, you can see that we have circled the factors that actually involve the movement of water internally inside the grain mass. Keep in mind that the presence of water will feed into mold, and when mold grows, it will produce bad odors, spoilage, and at the same time compaction, meaning that the feed ingredients or the grain will stick together, that is making it harder to unload it once we need to move it throughout the feed production. When we talk about condensation, it will occur inside any type of storage structure in different ways. The most common that you see in locations where they have tropical or semi-tropical weather is when you have a hot day, then at night it cools down. Due to the high relative humidity, during the day it will stay a little bit lower, but at night, when that water in vapor form comes in contact with the cooler temperatures that are transmitted through the walls and come inside through the air inside the grain storage, structure, then that water will condense into liquid and then will drip into the grain mass. When it comes with contact with those grains, then that will activate the mold that can produce bad odors. It could spoil the grain and, of course, in some cases produce mycotoxins. The other cause that you could see condensation occur in a metal silo is when you have internal movement of heat. Every time there's movement of heat from a warm location to the cooler side of a grain storage structure, it could be a bin, it could be a concrete silo, it could be a warehouse. When that movement happens, there's always going to be movement of water too in vapor form. Then when it goes into the cooler side, it will create condensation. Also, water can come inside a metal silo due to leaks of holes that come water dripping inside when it rains, or outside you have maybe snow or any other type of precipitation. Keep in mind when you're seeing these pictures that that's a cause of having condensation that activated that mold to grow. The picture on the upper left-hand corner of the slide, you see here how corn kernels got stuck to the wall. And that happened because you had that hot day. Then when it got cool, that water went from vapor to liquid form, kind of like drip, through the walls, came in contact with the grains, making it to compact. As that mold continued to grow, eventually will spoil that grain. And that's an effect that when you see compaction, the cause of it is that then grain will not move out, or any other product that you're storing. And that causes sometimes with problems with the handling equipment and then getting that product out, that in some cases gets people inside and they could eventually get trapped, going into the issues of worker safety. As we move down to the picture in the lower left-hand corner, you see that there was some condensation that occurred, water drip into that grain mass, then starts mold growing, releasing heat, and eventually burning that product. If you see the picture in the upper right-hand corner, that's something very important to keep in mind as we talk about storage. This is a small silo or bin, typical use here in the United States at the farm level, but the concept is very important for demonstration because you see here that there's this column full of grain that is compacted or stuck together. And that happens due to, of course, condensation that made that mold growth, but also because keep in mind that when we store grain or any oil seeds, there's a percentage of that void space inside of that volume that is just air. Typically 37 to 40% of any volume of storage of grain is just air. So when you have corn or any other grain that has a lot of dust, broken pieces, or fines overall, they will collect directly just below where that grain bin is being unloaded or filled out, which is just that's what we call that central core that you see here in this picture. So that void space in between the kernels when they're touching each other will get filled out by those dust and broken pieces, with eventually when mold comes in, they'll keep that heat, making that mold grow even faster, and then eventually spoiling that grain or making it even burn. Below you see in the lower right-hand corner some soybeans that were actually burned because of mold growth that eventually were spread out through a bigger mass. As we continue seeing the different factors that affect grain during the storage, now we're going to see what is called the hot spots. Hotspots are caused when mold starts growing inside a grain mass or a soybean mass or any of the co-products like DDGs or soybean meal. It's called self-heating due to the chemical and biological effects that is happening inside that grain mass. So since grain is a good insulator, that heat doesn't dissipate. So it stays there and the temperature starts going and increasing up to a point that it will end up burning the product. And that causes a loss of deterioration of overall quality and eventually loss of the material too. We started talking about molds, but here we could see it here on the diagram of the factors that affect grain storage. Keep in mind that molds are everywhere. They're in the walls of the grain bin, they're in the air, they're in the surface of those grain kernels. The key to control them is to reduce their growth or prevent them from growing. So molds, in essence, cannot be avoided, but we could control their growth. And to reduce that, we need to keep the grain at safe moisture content levels, meaning moisture contents where there's not enough water for the molds to grow. That level will depend a lot where you are located. In places where there's warmer and more humid locations, then you need to have a lower moisture content. In the United States, that is a typical temperate weather location, corn is kept between 14.5% and 50% because of the cooler temperatures on average year-round. Keep in mind that mold can produce mycotoxins during storage, but mainly the molds from the family of the Aspergillus. Also, another cause of mold growth is when we start grain at different moisture contents, because keep in mind that moisture tends to move to all the grain mass to equilibrate itself. So if you have grain that is very wet and then grain that is very dry, the grain that is dry will absorb moisture from the wetter. That's good for the wetter grain because it will lose moisture, but then that whole movement can cause mold to grow. Another factor that affects grain during storage is the broken grain and foreign material. That is pretty much all the dust, broken pieces, fines that can accumulate. That is caused more by cereal grains, not necessarily by oilseeds. But their accumulation can create the mold to grow because of all the heat that accumulates, and also because mycotoxins and insects tend to concentrate more where there's broken pieces. So the presence of that broken grain, dust, foreign material can cause several issues. Among them, if of course it will affect grain preservation, and that's where mold will accumulate, insects will feed, because insects, there's a specific type that can only eat broken pieces because they don't have a snout that will let them drill the kernels. So those species are the ones that are part of the external feeders. Also, as it was mentioned, broken grain has usually a tendency where mycotoxins tend to concentrate, and when they're being stored inside a grain bin, and you're trying to do aeration to cool down that grain, that concentration of broken pieces and dust will affect the airflow distribution. Another factor that affects grain storage is pests. Pests could be rodents, it could be birds, but also it could be insects. So we're going to focus a little bit more talking about insects. Insects and the other pests like rodents and birds can be avoided up to a point. There's always going to end up having some of them presence, but the key thing is to try to reduce their population to the levels where it doesn't affect the overall grain or any type of feed ingredient that you're storing. The best way to control insects is to eradicate them using pest control programs like an integrated pest management or IPM program that utilizes fumigation as a chemical alternative as the last resource. Insects that attack grain usually behave a little bit like humans, meaning that they feel more comfortable during a specific temperature range. Between 25 and 32 degrees Celsius is their optimal growth, meaning they will eat more and they will reproduce. As the temperature goes up, they will not feel comfortable. And also, as the temperature goes down, they will not feel comfortable either. That's what is in essence to keep grain as cool as possible, to avoid insects from eating more and reproducing, and also mold. Because if you remember what I said a little bit earlier, mold tends to grow faster or exponentially when the temperature is higher than 28 degrees Celsius and relative humidity higher than 65%. So keeping the grain or any feed ingredient as cool as possible will avoid these two factors to grow. Another factor that affects grain during storage is the overdrying, or that causes also shrinkage. Shrinkage is the factor when we have inventory loss. It could be caused by different ways. One of them is the loss of moisture to the environment, because keep in mind that grain isn't a biological material. And in fact, all feed ingredients in the majority will trend to equilibrate with the weather conditions where they're located. So if you live in a place where there's high relative humidity, meaning high amount of water up in the air, then that moisture will tend to move into the grain if the grain is dry. If the grain is wet, then it will lose moisture into the environment, and that will cause also, of course, shrinkage. Another cause of shrinkage is the losing of dust up to the environment of the broken piece of grain, and another one is when we do overdrying. And that is not an issue that can be controlled really by feed millers, but is more in the place of origin of that corn, being local or imported. When you dry grain, specifically corn, at very high temperatures for a very short time, then the moisture will move very quickly out of the grain, causing it to have some issues with the structure. When that happens, then it becomes burnable. So when you're moving all that grain throughout all that handling equipment, through the transportation and into your facility, all that hitting against the metal can cause it to break more easily. And that breakage will create more fines and more dust that could be lost into the environment or could be lost through the handling equipment, causing shrinkage. So it's very important to understand all the factors that can cause your shrinkage, because when you do your accounting part of based on the inventory, you need to know what you're losing to the environment, how much weight you're losing to water loss, and all the different factors that could affect that. This concludes part 1 of the presentation of storage and grain quality management. Please continue with part 2.